Hello students, my name is Teacher Bonfa, math physics teacher at Boqol.
Now, our length was
We shall continue forces. In our previous
volume the big cylinder.
forces are
74. We have
the categories of forces.
8,
We have two main categories of forces,
28.
the conduct forces and the non-conduct forces. Then we narrowed down and looked at the individual types of forces, where we looked at the gravitational force, we looked at the tension force, we have looked at the updraft force, we looked at the cohesive and adhesive forces. Now we shall be continuing to look at the particular types of forces. And today we shall look at a type of force we call magnetic force. Magnetic force. As we know that a force is a
Take away now.
pulling an object, it is equivalent to exerting a force on that particular body.
The mark
Of magnetic force, what force is it?
was 9. So our answer was 9.
Metallic substances which have a capability or a tendency of attracting other materials. A magnet has a possibility of attracting a metal, and it has a capability of not attracting other type of materials. Materials which can be attracted by a magnet are called magnetic materials.
Type
Materials
back it out. And
which can be attracted.
class.
A magnet. We call them magnetic materials. And we have materials which a magnet has no capability of attracting them. Such materials are called non-magnetic materials. Non-magnetic materials. These are materials
It's a very simple question.
which cannot be attracted
How to pass it?
a magnet. So that means that magnets just attract any kind of material. We have materials which a magnet can attract, and we have materials which a magnet cannot attract. So what are examples of magnetic materials? Examples of magnetic materials include examples of magnetic materials. Number one, we have iron. A magnet has a capability of attracting an iron material. We have a material called cobalt. We have a material called nickel. Example 4, we have a material called steel. Those are examples of materials which a magnet has a possibility or a capability of attracting. But we said we have materials which a magnet cannot attract, and we call them non-magnetic materials. We have examples of non-magnetic materials. They include, I can write them here, examples of non-magnetic material. We have rubber. A magnet cannot attract a rubber material. We have wood. We have plastic. Those are examples of non-magnetic materials. Now, what therefore is a magnetic force? A magnetic force is a force which causes attraction or repulsion by a magnet. A magnetic force, we define it as a force causes attraction or repulsion by a magnet. A force of attraction or repulsion by a magnet. We just said that a magnet can attract materials. So what is attraction and what is repulsion? To attract an object, it is to experience a force pulling the two things together. Assuming this was a magnet, and this is a magnetic material. When I bring the magnetic material closer to this magnet, there is a force which the two materials are going to experience, pulling them towards each other. Then we say, when objects are experiencing a force pulling them to each other, they are being attracted. Likewise, we have repulsion. Repulsion is the opposite of attraction, where the objects now are experiencing a force which is pushing them away from each other. Remember, a force is a push or a pull. So objects can be pushed together or can be pulled together. When the objects are being pushed together, that is an attraction. When the objects are being pulled apart or away from each other, that is a repulsion. So magnets can cause attraction of materials, at the same time repulsion. Now, attraction by a magnet can take place in two ways. A magnet can attract a magnetic material, as I said earlier. And we have given examples of magnetic material, that if I bring an iron rod close to a magnet, the two are going to experience a force pulling them to each other, closer to each other. And therefore that means that the objects are being attracted. What about repulsion? I said to repel is to experience a force pushing two objects apart from each other or away from each other. When does repulsion take place? Repulsion takes place when a magnet is brought close to another magnet. But in terms of poles, a magnet has got two ends. The ends of a magnet, we call it poles. So any piece of magnet has got two ends, and the ends of a magnet are called poles. One end of the magnet is called a north pole. Yes, good morning. A south pole. So if I have two pieces of magnet and I bring them closer to each other, two things can occur. Either attraction can occur or repulsion can occur. When will attraction take place and when will repulsion take place? To start with this, attraction takes place if I bring opposite poles close to each other. This is magnet A, this is magnet B. And I'm bringing a south pole of magnet A closer to a north pole of magnet B. The two magnets are going to experience force just pulling them towards each other. And therefore, attraction taking place. So attraction can take place between a magnet and a magnetic material. Attraction can take place between opposite poles of a magnet. What about repulsion? Repulsion takes place when I bring a magnet close, but in such a way I'm bringing close to each other. A south pole brought close to a south pole, or a north pole brought close to a north pole. Then the two magnets are going to experience a force pulling them apart from each other. And then the repulsion taking place. So attraction is occurring here, while repulsion is taking place in diagram. Now, we said that a magnetic force is a force of attraction or repulsion by a magnet. A magnet has got two ends. The ends of a magnet are called poles. One end is called a north pole, the other end is called a south pole. When I bring a north pole close to a north pole, those are like poles. Then repulsion is going to take place. When you bring opposite poles of a magnet closer to each other, they experience an attraction force, a force pulling them towards each other. For example, a north pole and a south pole will be attracted. A south pole and a north pole will be attracted. A north pole and a north pole will be repelled. A south pole and a south pole will be repelled. So that is what we are calling magnetic force. Magnetic force causes attraction or repulsion. Experimentally, to demonstrate this force, we are calling magnetic force. We can demonstrate magnetic force using the following setup. First setup, we are using two pieces of magnet. We use a string, an iron bar, and iron filings. Our second experiment is,
which is 25.
A string. Now the piece of magnet with a string. And suspend. The magnet is suspended. This is a magnet suspended. Remember, magnet has got North Pole and the South Pole. So the magnet is suspended using a string. This is a string. This is a bump. Then we bring another magnet. We hold another piece of magnet in your hand and bring it closer to the magnet. We bring the magnet holding in your hand. This is a magnet in your hand. You're holding it in your hand. Bring it closer. Surface area. I'm bringing the North Pole closer to a North Pole of the suspended magnet. We just learned that when the poles are alike, repulsion takes place. What do I expect to observe? The suspended magnet will swing away. It swings away incoming pole of the magnet. This shows what action is taking place.
Triangular prism
Experiment that you can use to demonstrate the magnetic force. That if you suspend a magnet and bring another magnet held in the hand close to the end, if these two poles are alike, the suspended magnet will swing away from the incoming or the magnet which is held in the hand. But if the magnet held in the hand, you bring an opposite pole, assuming this was the south pole, and you bring it closer to the suspended magnet, and you are bringing it closer to the north pole of the suspended magnet. Those are unlike poles. As I said earlier, like poles attract. So this magnet is going to swing towards the held magnet in the hand. That shows attraction taking place. That is a simple experiment that we can use to demonstrate magnetic force. So more about the magnetic force, we shall learn it in Form 2 in a topic called magnetism. We shall learn about magnetic force in detail, look at experiments that can be used to demonstrate magnetic force, look at the application of magnetic force in so many ways in details in our next class, Form 2. We shall move to the next type of force. The force is called electrostatic force.
given. You must get the other side first, which is the square of 5, then minus square of 4, then
Electrostatic force. In so many cases, we have woken up in the morning, going to school, you take your brush, you brush your shoe, you're shining your shoe. For those, for example, who walk on their way to school, by the time you get to school, looking at your shoes are very dirty, dusty. Most of the times, we wipe our window panes in a very dry day. Then all of a sudden, after some few minutes, you come and observe the pen, you find it very dusty. Most of the times, you are at home, you want to sleep, then you are removing your nylon shirt in darkness, and you can hear some crackling sound and some sparks. What causes all this? Why are your shoes getting dirty? Why is the window pane getting dusty? Why is the crackling sound? Why are the sparks from your nylon shirt? All these are as a result of what you are calling electrostatic forces. So what is an electrostatic force?
or the measurement.
Electrostatic force we define a force of attraction. It is a force of attraction or
Before, and the length now you are
due to static charges. Due to static charges. Force of attraction or repulsion due to static charges. What are static charges? Static means not moving, stationary. These are charges which are not moving. We understand what charges are. Charges originate from atoms of a body. So when charges are on a body but are not moving, they are called static charges. And these static charges, they can cause attraction of a body, can also cause repulsion. A simple experiment we use to demonstrate electrostatic force, it is using a plastic pen. So, plastic ruler. You take a plastic ruler or your plastic pen and rub it in your hair, dry hair. You rub it in your hair several times and bring it closer to pieces of paper. Small tiny pieces of paper cut into small pieces. You cut a paper into small pieces and put it on a desk. Take your plastic pen or your plastic ruler and rub it in your hair several times. Then bring the pen closer to the pieces of paper. We are going to notice something. The observation to be made here is the small pieces of paper will be attracted to the pen. And when you try to lift the pen up, it will be lifting those papers. And the papers will be sticking on the pen or the ruler. This also is as a result of electrostatic forces. How? When you rub the pen or the ruler in your hair, the pen gets charged. The pen obtains static charges. The pen obtains static charges. Now, when you bring the pen closer to the pieces of paper, what happens is the charges on the pen induces an
plus pi dh
on the surfaces of the paper. So rubbing the pen gets charged, attaining either negative charges or positive charges. So when you bring the pen closer to the pieces of paper, those charges on the pen are going to induce a charge which is opposite to the charges on the pen on the pieces of paper. And you'll find out that opposite charges are going to attract. If my pen was negatively charged, those negative charges on the pen are going to induce positive on the piece of paper. I have negative charges on the pen, positive charges on the paper. Those are unlike charges. Unlike charges will tend to attract each other. So the paper will stick on the pen because they are being attracted, because they seem to be containing a charge which is opposite to the charges on the pen. So in this case, rubbing an object makes the body to be a charge. It attains charges. But those charges are not charges which can move. They are charges which are just found on the surface of the object. And in fact, if I rub my pen in the air, dry hair, and then wipe it again with my hand, bring it close to the pieces of paper, the pen will not be able to attract the pieces of paper. Why? The charges are on the surface of the pen. So when I wipe it, it's like I'm tapping the charges. They flow through my body to the ground. So the pen loses the charges. Those charges are static. They only stick on the surface of the pen. So the pen,
like fire squared, the put square top at the bottom, then pi dh is surface
attain
of side,
and the two will be
to stand up.
Paper will stick on the pen and can be lifted up using the pen or the plastic ruler. The same can be used to explain why the window panes are getting dusty after wiping them in a dry day. When you wipe a window pane with a dry piece of cloth, what you do is you are charging the glass surface. The glass surface will attain positive charges. So if the dust particles are moving, remember dust always flows in air. We have what we call wind. Air is always in motion. As the wind moves and as the air moves past the window pane, the charges which the glass has attained is going to induce an opposite charge on the dust particles around the window pane. Once they attain an opposite charges attract. So the dust particles are going to be attracted on the window pane and they make the window pane appear dusty. When you brush your shoe in the morning, what happens is the shoes are charged through rubbing. and the shoes are charged, they attain charges. We have two types of charges. We have negative charges.
This area,
The shoe gets charged, either attaining a negative charge or a positive charge, depending on the nature of the material. And you find out that when you are walking on your way to school, the charges on your shoe induces an opposite charge in the dust you are passing through. The dust on the ground as you are walking, it induces an opposite charge. Once the dust attains an opposite charge, it is going to be attracted to your shoe because opposite charges attract. If your shoe was negatively charged, the dust particles around the shoe attains a positive charge. Then they get attracted to the shoe. That's why when you get to school, your shoe looks very dirty, dusty. It is because of what you're calling electrostatic forces. And the charges are attained through rubbing. So there are so many questions you might come across in the exam. You are told the most common questions I give you about this one is what I've talked about. Come on
here now,
and you must be in a position to answer such questions. Number one, explain why the shoes get dusty after being brushed. When 8 in the morning on your way to school, by the time you're getting to school, your shoes are very dusty. They look like they were not brushed. It is because of electrostatic charges. We have explained. We have said that when you brush your shoe, the shoe gets charged. It attains charges, either negative charges or positive charges. So as you walk on the ground, the shoes or the charges on the shoe will induce an opposite charge in the dust. And therefore, opposite charges attract. So the dust particles will be attracted to your shoe because they are obtaining or containing a charge which is opposite to the charges on your shoe. Question number 2. You'll be asked to explain: a student wiped the window pane with a dry piece of cloth on a dry day. After some minutes, the window pane was dusty. Explain. The explanation to both questions are the same. Just remember, we have said when you rub a body, it attains charges, either negative charges or positive charges. So an object which is positively charged will induce an opposite charge to the object closer to it. So you must be in a position to be able to answer these questions. Number 3, a last question here. You can also try answering these questions. Number 3, a Form 1 student was removing a nylon cloth from his body in a dark room. In a dark room. He observed bright sparks, and could hear, get back at the top here, and could hear some crackling sound. Explain this observation. Explain this observation. So those are 3 common questions you'll meet as far as electrostatic forces are concerned. So Having learned electrostatic forces, make sure you are in a position to answer and explain very well these questions. Explain in details what is happening here. And remember, a question which is asking you to explain is a very tricky question. You might think you got it right, but there are some specific terms that the examiner normally looks at. A question that says explain, make sure you are able to elaborate everything. What causes this? What happens? Then in details completely. Don't leave any important words aside in your explanation. Give complete details. Now, our next type of force is centripetal force. Centripetal force is another type of force that we need to discuss here. It falls under non-contact forces. Remember, we have two categories of forces. We have contact forces and non-contact forces. So centripetal force, this is a non-contact force. Centripetal force. Now, what are centripetal force? Most of you students have gone out to enjoy, maybe on holiday. You go out in the parks and you play on something, you normally call it a merry-go-round. Merry-go-round. Now, if you are very keen, when you are on a merry-go-round, the moment it's switched on, it starts going round and round, slowly by slowly. Then all of a sudden the speed increases. And as the speed increases, you find that it starts rising up, and the circle becomes bigger and bigger and bigger and bigger. Now, as it is still in the motion, making circular motions, the operator comes and switches it off. You find that the merry-go-round does not stop immediately. What happens? It continues to move in that circular path, making circular path. Then slows down, the circular path decreases, and then finally it will stop. Now the question is, how comes now the merry-go-round is off? It has been switched off, but it's still in motion. It is still making circular motions. We are going to explain that. Number two, if you take a rope and tie a stone on the rope and hold the other end of the rope and start swinging the rope, making circular path. Move it very fast. Then stop moving. Hold your rope tightly. There's something you're going to notice, that the moment you stop rotating the stone or the rope, the stone will keep on making circular path, yet you are not moving it. There's no force you are applying on it to make it go in a round circle. So what is making the stone to continue moving in a circular path, yet you have stopped making it to move in a circular path? Now, all these observations are due to our force. We are calling it centripetal force. Now, how do we define centripetal force? Centripetal force is a force that constrains a body to move in a circular path. A force that constrains a body to move in a circular path, we call it a centripetal force. A force that makes a body to move in a circular path, we call it a centripetal force. Back to the merry-go-round. So when the merry-go-round has been switched off, it continues to go, making circular path. The merry-go-round is going through making circular paths because of what you're calling the centripetal force. It is off, but it continues to make a circular path. So there is a force which is making it to continue moving in a circular path, and that force is called centripetal force. The same thing occurs when you are swinging the stone. The moment you stop swinging the stone will continue making circular paths, and that is also because of centripetal force. So centripetal force is a force which constrains or makes bodies to move in a circular path. Now, about centripetal force, what you must know is applications of centripetal force. How is centripetal force applied? Applications of centripetal force. One, I've already talked about it. The first application of centripetal force is in a merry-go-round. Merry-go-round. The centripetal force is applied in a merry-go-round, making the merry-go-round to continue making circular paths, circular orbits. Number 2, it is applied in a sling. A sling is an instrument used for hunting. With a sling, it has got 2 ropes. It contains 2 ropes. And the ropes are tied to a leather material like that. So 2 ends. So you take a stone, place the stone here. Then you hold the 2 ends of the rope. Then you start rotating the rope while the stone is held in here. You rotate it very fast, and then you throw. When you're throwing, you throw 1 rope and hold 1 in your hand. So you find that the stone gets out at a very high speed. That's what you're calling a sling. It is an instrument mostly used for hunting. So a sling serves or operates using the centripetal force, makes application of the centripetal force. When you are making circular paths, you find that the moment you want to throw it, you are no longer applying the circular force. You're no longer making a force to make it move in a circular path, but the stone will keep on going in a circular path. And that is because of centripetal force. Number 3, another application of centripetal force is separating ghee from milk. Separating ghee from milk. Ghee is a product of milk. So at the industry levels, when you want to separate ghee from milk, they use what you're calling machines. They are machines which apply centripetal force. They have containers, and these containers are meant to go in a circular path. As they go in a circular path, you find that the 2 are going to separate. Milk at the bottom and the ghee on the top of the milk. So they can easily obstruct or remove the ghee from the milk and obtain with the milk. So the machines work by applying centripetal force. Now that brings us to the end of centripetal force. Let's move to another type of force. This is our last type of force we are going to look at. And the force is called surface tension. Surface tension. Surface tension. Which type of force is surface tension? Now, surface tension, we define it as, definition of surface tension as a force. It is a force that makes the surface of a liquid to behave like a thin, elastic, stretched skin. A thin, elastic, stretched skin. The surface of a liquid behaving like a skin, which is thin and it's elastic. Something which is elastic is something which can stretch, become large, can reduce in size. So we have a force which makes the surface of a liquid to behave like that, like it is a skin which has been stretched. That is a force we are calling it surface tension. Most of the times we have seen insects on the surface of a liquid. Therefore, why is an insect able to rest on the surface of the liquid without sinking? If you try to jump in your water, you will sink. But we have objects which can lie on the surface of the liquid and they do not sink. That is as a result of what you're calling surface tension. There is a force which is making the surface of the liquid to behave like it is a skin which is stretched. Now, what causes surface tension? Before we look at the applications and so many things to do with the surface tension, we will need to understand what is causing surface tension of a liquid. In our previous lesson, we learned about a type of force called cohesive force. And we said cohesive force is a force of attraction between molecules of the same kind. And we are using an example of the molecules of water. There is a force attracting the molecules of water to each other. If this is water in a basin, we have molecules of water. And of course, on the surface, we have what we call surface molecules. These molecules, they are not free. They are attracted to each other by very strong forces. These are the forces we are calling cohesive forces. So the surface molecules are attracted to each other like that. So you find that the molecules of the liquid which are on the surface, they form a connection, a net connection of molecules, strongly held to each other, forming a strong bond. United, we are strong. So this molecule is attracted to this one is attracted to this one is attracted to this one, like that, forming a very strong bond. So this makes now the surface of a liquid to behave like it is a skin, which is tight and it's elastic. So when an object lands on this surface, it is capable or is able to rest on the surface of the liquid without actually breaking this bond. Once the bond is not broken, then the object will remain floating. So these forces which are making the surface of the liquid to behave like it is a skin, it is tight, elastic, and cannot be broken by any object landing on it, is what you are calling surface tension. So we have said what surface tension is. We have defined it as a force which makes the surface of a liquid to behave like a thin elastic skin. We have given the cause of surface tension. We said surface tension is resulting from the strong cohesive forces of attraction attracting the surface molecules. Now, we shall end our lesson at that point. We shall continue and talk more about the surface tension and the application of surface tension and questions which result from this type of force. Thank you so much, students. Meet you next time.